For the loop part, we need to create a method called public static void because it's a printing, and then the name of the method. We need to provide an end value, and that will help us to determine when we're gonna stop and when to begin. Depending on the way you want or the style you want to do this in a loop, looks like this. The most naive way to do it is that I, your control variable, shall start at the value that you want to provide. Forget about this. The only thing we have to do, as long as I is greater than or equal to 1. Why is 1? Because that's when we need to stop printing. Remember that this method should print 5, 4, 3, 2, all the way to 1. So the next question is, how would your control variable be updated? Well, if you notice, it will start at 5 or at n, and it will go all the way to 1. This is our base case, in other words, when we're gonna stop doing this. And the way we're gonna update our control variable is nothing by going one by one, but in reverse order. Therefore, I minus minus. What would the body of the loop do? Remember, we have to repeat the printing value of I. 5, 4, 3. So how does that loop look like? So it's not a print line, right? And actually not print line, but we're just gonna print the value of I, and I ask you to put some commas there, just in case. If I save, compile, and run this program, let's see what happens. We got 5, 4, 3, 2, 1. So we got that. If your OCD is as picky as mine, what I would do is that I go all the way to 1 with a comma. And the only thing I will have to do here is to print outside of the loop the value of I. This won't work because I at this point, it's already undefined. Check this out. If I compile this program, it will give me an error. It says, you know what, cannot find the symbol of I, because you save it in the actual scope of the for loop. You can still do this if you want to. I just recommend to migrate outside, and that will work. If I save, compile, and run my program, let's see what happened. That is exactly the loop that we're looking for. 5, 4, 3, 2, and the number 1 at the very end, without the comma at the end. So now that we have here, might as well we would like to use a while loop, no? I mean, this looks a lot like a while loop. As a matter of fact, let's try to translate this into a while. If you notice here, we already have this, the int I. The only thing we have to do is just transform this part here, and this part should go all the way down here. As a matter of fact, if you don't mind, what I like to do sometimes is just do the minus minus I. Let's see what happened. The same result. I want you to pay an extra attention on what we're doing. If you notice, it's exactly the for loop that we're used to do. But at the same time, there's a couple of different things that we're paying attention. Int I is outside of the actual loop. As a matter of fact, that help us to just have a more external control. But if you think it's a little bit redundant, it is redundant because we still have the value of n here. The only thing we're doing here is that we're borrowing the value of I to just mask the value of n. Might as well use n, no? Let's give it a try. I'm gonna comment this piece of code so you can see the history of what we've been doing. What I'm doing here is that since n gives us the control of the value here, might as well you say, you know what, as long as n is greater than 1 minus minus n. And the only thing I have to print here is the value of n. In other words, we don't need an extra variable for the control variable. We can control the entire loop by using n. Let me just compile the program and run it again. Hopefully nothing changes. As a matter of fact, if you can see, it's the same output. Very nice, no? So this is the way you simplify a for loop. The next step is to come out with the recursive version. How does it work? If you don't mind, I'm just gonna comment this out, and now I'm gonna call it print reverse rec for recursive. The first thing we need to understand is to establish the base case. Base case means whenever you need to finish. Whenever you complete the task, that's how you get out. If you think about it, the base case is right after the condition gets satisfied. In other words, you just need to flip this part and you will have the base case. Remember, everything that runs inside of a while loop is called recursive, but the base case is the opposite of that condition. Therefore, if n is equal to 1, then that's time to leave. And the way we leave is to just basically the same way we print outside of the loop. We just migrate this instead of the if statement. The opposite of n equals to 1 is the else. This is what we call the recursive case. A recursive case is basically this condition that you can see here. And in that condition basically says system.println n, and then we decrement the value of n. This won't work because we still have to call the recursive call, which is print reverse rec. So when we do this, the only thing you have to do is to pass the value of n, which we already have. Let's save, compile, and run this program. As you can see, we got the same result. And we didn't use any loop. This is called recursion. Recursion does not take any kind of loop. However, it basically performs the same action because you call yourself again and again and again until the base case is satisfied. We know when n is equal to 1, the only thing we have to do is to print that value of n and get out. However, if it's not true, then we're going to call ourselves by using the recursive case. Before, we just print the value of n in a comma, and then we decrement this value and we update. Wait a second. As a matter of fact, we can save a couple lines of code. Instead of having the minus n here, what we can do is just put it here. Let's see if that works. If I save and compile this program, we got the same result, which is what we want to satisfy. Recursion is elegance in terms of the number of lines of code, and we achieve a good amount of code.